Hello everybody, today I would like to show you how to simulate a wireless power transfer system in Ansys Maxwell 3D. The wireless power transfer system including two windings like this. The separation between them is 5 mm. For one winding, its inner radius is 10 mm and it including 10 turns, and coil pitch is 1 mm. Coil pitch means the distance between center of one turn to the center of the other turn. And here is a cross section of the coil. It thickness a 0.07 mm and it width a 0.5 mm. Okay, now we will start to simulate this system in Ansys Maxwell 3D. See it. Okay, right click on the project, click on insert Maxwell 3D design. Okay. Now I will choose the solution type. Here we want to calculate the coil inductance and resistance, so we choose magnetic type. Here I choose electric current because I will simulate my wireless power transfer system at a specified frequency, for example 50 kHz. Okay. Now I will create the first spiral. Draw user defined primitive, segmented helix, rectangular. Okay, here rectangular height is Cooper thickness, it's 0.07 mm. 0.07, rectangular width is 0.5. Inner radius of the coil is 10 mm. Radius change is, it means coil pitch is 1 mm. Here I set the pitch here is 0. If not, the coil will not be spiral, it will become helical coil. The turn number is 10. Segments per turn is 36.5. Click on OK. Okay, now we have the first spiral. Because the current in the coil need to form a closed loop or closed path, so we need to make a terminal for it. Okay, now we will make terminal for it. Click on draw line here. Select the first point, for 20 something, yeah, 20 here. Click on here. First line. Second line, click somewhere. Third line. Fourth line, and the fifth. And we need to connect it. Okay. Right click, done. Okay, see the line, and we need to modify a little bit. The first point is 20.00. Secondly, for example, we can set it here as 1. Apply to check whether it works. Click OK. And the second line should be on the Z direction. Second line here, because it will need to be lie on Z direction, so the X value is still the same, and the Y value is also still the same, given on here, and we set the height of the line is say 1 mm. Select OK, apply and OK, and here we need to set this second line. Here I set here at 10 mm, and its position here is 1, and X and the Z is 0. Fine. Okay. Okay. And we need to set the parameter for the fourth line 1, 0. Here. I'm sorry, we need to check here a little bit. Here it should have a height, for example 1 mm. Click OK. And here the fourth line we rely on the XOY plane, so 10 here. Oh, the default light. So the Y should be the same -1, and the Z should become 0. Okay. Okay. And this is the last line. Okay, cool. Now we have the terminal. It light terminal. Okay, now we need to select phase F. We will need to create a phase, and that phase will sweep along the polyline on here, so it can become a terminal for the coil. So select phase, draw, model, surface, and create object from phase. Okay. Now we will sweep this phase across the polyline on here. Draw, sweep, and along path. Okay, it's nice. Okay, I'm sorry. This one look not good. This terminal. So we need to change it. Take the polyline here. Phase here good already. Let's see. Here we need to create a line here. Okay. Okay, let's try another way to make the terminal, because now the gap here, if we simulate it, it will get error. So let's try another wave. Ctrl Z. Okay. And here we have the surface in rectangular. How we can do it? Let's rotate the terminal. rotate it. Rotate according to the z-axis, y-axis, for example. This is, I think we should rotate it along to y-axis with 90 degrees, for example. That's okay. Check where it is. Control B. Oh, it come here. No way. Delete it. Here I want to rotate the rectangular, so it still have be the same point here. Or as a wave. Okay, no problem. I think I will make another rectangular. Select rectangular here. Click on point of this cross-section. Make another point here. Okay. Let's try it wave. Delete here. Okay, now we have this cross section. I will make it bigger a little bit. See here I said okay 0.07. Why here I said it's slash 0.35 or 0.1. 0.5 for example. X side will be minus 0.4 something, and y side minus 1. Let's check it. Okay, it's too big. Zero point 0.2. Okay, 0.1. Y side here is too big, that I said 0.35 and 0.5. Okay, I make a cross section on it, a rectangular on here, and we wish to sweep along a line for make the terminal. Okay, now I will make terminal, sweep it to GX plane here, and now draw line. Like 1 point like here, 0, like some point 0.6. Okay, 0.6 here. Okay. Change it to 0, and here we set it. Right click, done. 0 something. Okay. Okay, now let's sweep the terminal with rectangular along the polyline. See what happened. Draw sweep along path. Okay. You can see the terminal is fully incorporated here. Okay. Here I think the terminal should go about here a little bit. So let's check. Zero 06. Okay, now we already have one core. Let the terminal be like this. I think it will fine. Now we will unite with rectangular and Z helix. Unite them together. Unite. Okay. Now we have a core, but now we need to make excitation so that the current can flow through this coil. To make excitation, let's do Z wave. Change the plane to Z and wave. Z wave. And here I will make rectangular. Here, and I change the position of rectangular to the middle of the coil so that I can make intersect to make the coil excitation. Z on here. X here is about 15. It here, but it got too high. So from on to live. This size should be about, say, -1. That's 5. Let's check. The rectangle still cuts the coil, so we reduce it a little bit. 0.7, 0.8, for example. Okay. Now the rectangle have cut the coil here. And I select the helix, Ctrl C, copy it, Ctrl V. This did not happen anymore. Okay, here we have the second helix. And now we select the second helix, rectangular helix through here, and click on the rectangular here, and we intersect. Okay. Now we can see we have a small rectangular here, and we will use it on for excitation of between two coils. Is it on? Okay, is it on? We don't need. We can delete it. Delete. Okay. And now we can make excitation for it. Select the rectangular. Make the name. I rename this coil like Coin. enter, change the material to copper. Okay, ready. And now setting, for example, TX excitation here, and right click excitation, select current, set current name is TX coil or transistor, value here 1 ampere, as I select the solid chance because this is PCB winding. Click OK. Okay, now we have the transistor coil, and we need to create a receiver coil. I will create it by select. The process is similar. You can do it manually, but I prefer to make a copy for it. Like select transistor and TX excitation. Now we will move it. Duplicate along line here. Type 0, 0, 0, and we duplicate along the z-axis with the distance of 5 mm. 5 mm is the distance between two coils. 5 mm here. Enter. Okay. Here I rename it as receiver. Receiver here. Excitation. Okay. Now let's make a battery for the coil. Select battery here, region here. Absolutely offset means the distance from battery to the coil. I set it about 700 mm. So the bigger battery, the more exact results, but the simulation time is longer. So click OK. Here we have the battery here. Okay. Now we can hide it. Hide the battery. Select object and hide. Ctrl D. Okay. Here we have on excitation, and we need to make excitation for ice coil. Current here, X here, equal 1 mm, 1 amp, and phase is minus 90 degree. Phase 90 degree because the current on transistor coil will create a current on receiver coil which is lag by minus 90 degree. Click OK here. Now we need to add a matrix for the inductance. Click parameter assign matrix. See both of them. Click button and OK. Next step is make setup analysis and solution. Number pass is 10, percentage error is 1, coverage, solver frequency. Here I choose like 50 kilohertz. Frequency of no. Click OK. Now we save the file. Now we see. Okay, there is no error. There is no error. Just one warning, so it's fine. Click OK. Save the file. And now we simulate it. Sorry. Simulate it. Analyze. Yeah, there is one license error here. Wait 2 minutes. click on APC and analysis option. Right click here, assign it on task and on core. Click it. If we want to simulate multiple tasks for one simulation, we will select the APC and we can select change the number of tasks and number of core here. But here I just have one setup to simulate, so I will change it to one task and one core. And click OK. Click OK. Right click on setup and analyze again. Here's the terminal look not good, but hope that the terminal here, ideally they should be touched together, but hope that it will not make any error, because now we just want to simulate it. Here we can see the number of messages on. If we click on right click on result solution data, we can have the profile conversion, the pass number, and the number of tetrahedra. Result solution data. Okay. Okay, simulation has been finished. Let's check the results. Right click on results, create eddy current report, data table. Here we can see the inductance value. ISIA, THEX, okay. Okay, here is the inductance, the self-inductance of the TXN of the ICE coil is 3.9. It will be the same for TX coil because they are identical. And here, LRHTX here is a mutual inductance between two coils. Here we can see like coupling coefficient at chase. And here we can see that the coupling coefficient between two coils is 0.5. Click on resistance. We can see the resistance between two coils. The resistance of two coils at trace here. We can see the ESR of both coils is around 464.9 million. If we want to see the distribution of magnetic field, click on coordinate system. Now plane. Select the field on the Y plane. See Y plane here. Right click, field, P field, magnitude. Done. Okay. Here is the field distribution between two points. Now we hide it. And if we want to see the message between two coils, we select both of coils, right click, plus mesh. Done. Okay, now you can see the message two coils. They look good. Everything is done for electromagnetic simulation of wireless power transfer system. In the next video, I will show you how to use circuit simulator to simulate a wireless power transfer system based on the parameter that we obtain from Maxwell simulation. Thank you very much. If you find this video useful, please subscribe.